Chem. Today we have another worksheet on percent composition, so we have more practice problems to do, and I just want to do a few together on this video before you went and got started on your own. So the first one we're going to do is number 1, and it's finding the percent composition of magnesium nitrate, which is Mg parentheses NO3 and parentheses 2. So in magnesium nitrate, I have 1 magnesium, I have 2 nitrogen, because I have to distribute that 2 throughout the parentheses, and I have 6 oxygen, because oxygen has a 3 subscript, and then we have to multiply it by the 2 subscript that's outside the parentheses. So first thing I need to do is find the total molar mass of magnesium nitrate. So magnesium's molar mass is 24.31 grams, plus I'm going to have 2 times nitrogen's molar mass, which is 14.01, plus 6 times oxygen's molar mass. Okay, once I add all those together, I get 148.33 grams. So that is the total mass of the substance that I will be using to find the percent of each element in this compound. So I'm going to start with magnesium, who has a molar mass of 24.31 grams. I'm going to divide it by the total molar mass, 148.33 grams. I'm going to multiply by 100, and that is equal to 16.4%. Okay, so usually I like to carry 1 or 2 decimals. Technically, for this problem, using sig figs, you could report up to 4 sig figs, so I could use 2 decimals here. So that is the percent of magnesium. Next, I'm going to find the percent of nitrogen. I have to find the percent of all of the nitrogen in the compound, not just 1 atom of nitrogen. So I do use this total of 2 times 14.01, which is 28.02 grams, divided by 148.33 grams times 100, and I get 28.9%. Nope, sorry, 18.9%. Sneak peek at the answer to another problem there. 18.9% nitrogen. And then finally, I need to find the percent of oxygen. So I'm going to take its entire molar mass of 6 oxygen, which is 96, divided by 148.33 grams times 100, and that gives me 64.7%. Okay, so this is 64.7% oxygen, 18.9% nitrogen, and 16.4% magnesium. So that was all number 1. The next one I want to talk about is number 4. I'm not going to do this entire problem with you, but I will do the first part of finding the molar mass. Okay, so number 4 deals with what we call a hydrate, specifically a hydrated salt. And I did talk about this a little bit in the notes section, but we haven't done much with them yet. So this is just kind of like a little introduction to them. It wants to know the percent of water in this zinc sulfate heptahydrate. Okay, so zinc sulfate is ZnSO4. And to represent hydrates, these are molecules that are surrounded by water molecules. They incorporate them into their structure. So we always put this little dot here, which I always think of like a multiplication symbol, even though it's not. And then heptahydrate is 7H2O. So this is an entire molecule, an entire compound together. I want to figure out what's the percent of water in this compound. So the first thing I'm going to do is find the total molar mass of this compound. To do that, I'm taking the molar mass not only of the zinc sulfate, but also of the water together. So I'm going to take the molar mass of zinc, which is 65.38, plus the molar mass of sulfur, which is 32.06, plus 4 times the molar mass of oxygen, which is 16, plus I'm going to do 7 times the molar mass of water. So you could do 14 times the molar mass of hydrogen plus 7 times the molar mass of oxygen, but since water is staying together in this, I just kind of take 7 times the entire molar mass of water, which is 18.02. So I'm going to take 7 times 18.02, barely fit that in there. And this together is going to be the total molar mass of zinc sulfate heptahydrate. Okay, so that's how you do the total mass for that compound. Then to find the percent of water, you're going to take the molar mass of all the water in the compound and divide it by that total mass, multiply by 100. Okay. The final problem I kind of want to walk through together is number 7, which is located on the back of the worksheet. Okay. It wants to know how many grams of gold can be recovered from 45 grams of gold to chloride. Okay. First step here, I need to figure out, well, what is the formula for gold to chloride? From the periodic table, I know gold is Au. That 2 tells me that in this compound, gold has a +2 charge. So I have Au2+, and it's chloride, so that's Cl. Cl always has a charge of -1 in a compound. If I crisscross, I can find this chemical formula. So I'm going to have a compound that is AuCl2. First thing I want to do is find the percent of gold in this compound because it asks me how many grams of gold are in the compound. So I'm going to find the total molar mass of AuCl2, which is going to be 196.97 plus 2 times 35.45. And that gives me a molar mass of 267.87, sorry. Keep looking at the wrong problem. So 267.87 grams is my total molar mass for this compound. To find the percent of gold, I'm going to take 196.97 grams and divide it by that total molar mass I just found, 267.87 grams. Multiply by 100, and I find a percent of 73.5. Okay, that does not answer the question yet. I found the percent of gold. So that means if any sample of gold 2 chloride that I am given, 73.5% of it is going to be gold by mass. So my sample size that they tell me is that I have 45 grams of gold. Based on this percent, I know that 73.5% is gold. So I'm going to multiply by 0.735. Because again, I don't trust the percent sign on my calculator. Sometimes it ends up multiplying by 73.5 instead. I don't like that. I need 0.735. When I do that, I get 33.1. What is my unit here? Percent doesn't really have a unit, but my original unit was grams. So that's 33.1 grams of gold in that sample. Okay, so that is number 1, first part of number 4, and number 7. If you have any questions, please let me know. I will be in the Google Meets if you have a specific question or maybe you walk through something, or I'm also available on GoGuardian if you're more comfortable asking questions that way. Okay, have a wonderful day, and I will definitely see you in class tomorrow.